In this first question, we're asked to calculate the equilibrium constant, considering that we have 1 molar sulfur trioxide placed in a flask with 2 molar water vapor, and then the two react according to the equation provided. At equilibrium, we are told that the concentration of hydrogen sulfate is 0.2 molar. Now, because we don't know the equilibrium constant, nor do we know the equilibrium concentrations of 2 of the species involved in the reversible reaction, we are going to have to solve this problem with an icebox. And that's what the beginning of our solution should look like. So you see that the initial concentrations of the sulfur trioxide and the water vapor are recorded in the first row of the table, the I row of that table. And we have assumed that the initial concentration of hydrogen sulfate vapor is 0, because we weren't provided any details about it in the question. Now, the next major assumption that I have made in this solution is in the second row of the table, the change, or the C row. You see that I have assigned a negative sign to X for both the reactants and a positive sign on X for the product. And the reason that I've done that is that I've made the assumption that this equilibrium will proceed to the right. It's a reasonable assumption considering that I'm starting with both reactants but not with any product. So that's why the signs are as they are. That will allow me to write an expression for the equilibrium concentration of sulfur trioxide, and water vapor. And when I've done that, I can now use the information provided about the concentrations of hydrogen sulfate in order to solve for X, and that's the next stage of my solution. Now that I have a value for X, I can go ahead and use it in the equations for the equilibrium concentrations of sulfur trioxide and water vapor. So we find that at equilibrium, the concentration of sulfur trioxide is 0.8 moles per liter, and that at equilibrium, the concentration of water vapor is 1.8. Of course, we're provided in the question with the equilibrium concentration of hydrogen sulfate. Now that I know these 3 concentrations at equilibrium, I can substitute them into the equilibrium constant expression in order to find KEQ. KEQ is then reported to 2 significant figures in this question.